Welcome to the Deep Dive. Today, we're plunging into what many are calling a robot renaissance. I mean, it's not just coming, it feels like it's undeniably here.
It really does.
Our mission with this deep dive is, well, to give you a true shortcut, to help you get well informed about where autonomy is headed.
Yeah, we've waded through a whole stack of sources, including a pretty major report called Future of Robotics 2035, insights from industry experts.
And we've distilled the key nuggets. We're going to unpack the current breakthroughs, yes, but also the surprising challenges and the potential futures.
And we're doing this through the eyes of the people actually building, using, and, studying these autonomous systems.
You'll hear from a really fascinating mix, people in product management, organizational psychology, robotics evangelists, even construction innovation leaders.
Quite the range.
So let's unpack this first point. The report suggests we've hit a watershed moment in 2025. What exactly are they seeing? What does that mean for where robots are heading?
Well, it signifies a pretty fundamental shift. Moving away from simple automation, robots just following rigid commands towards true autonomy.
Okay, autonomy.
Yeah.
So machines that can perceive, learn, make decisions on their own.
Exactly. Perceive, learn, and independently make complex decisions. The report highlights that something like 82% of organizations have already increased their investment in automation.
82%.
Wow.
Why is the sudden jump?
Largely because of generative AI. That's the big catalyst mentioned. And kind of surprisingly, humanoid robots, which weren't really on the radar in 2024 predictions, they're now seen as a top emerging tech.
It really feels like, well, you know how water clocks took centuries to evolve? Now it feels like similar leaps are happening in months. The acceleration is just different.
You've absolutely hit on it. This rapid evolution, it's driven by this powerful convergence. You've got large language models, LLMs, digital twins, advanced simulation techniques, and multimodal sensing all coming together.
And this combination is creating, what? A new kind of robot.
Pretty much. A new breed of embodied intelligence. Robots with surprising dexterity. We're talking things like threading fiber optic cable or having the judgment to reroute around a fallen pallet in a warehouse.
That's quite a step up from just moving things from A to B.
It is. Amit Goel from NVIDIA put it nicely. He said, "We're standing on the shoulders of large language models to build a new generation of intelligent robots that can see, think, and act in the physical world."
Okay, this rapid acceleration. It sounds amazing, like sci-fi promise, but let's be honest, it also brings a bit of unease, right? The classic robots versus humans narrative.
Yeah, that narrative is strong.
Do these experts buy into that zero-sum game? Or is there a more collaborative vision emerging?
That's a really critical point the report tackles. It emphasizes this strategic imperative. We have to capture the power of these innovations, but we also have to safeguard human judgment, creativity, purpose.
So not replacement.
Exactly. The report argues that autonomy's often been treated, maybe mistakenly, as a zero-sum substitute for people, either. Instead, the focus really needs to be on championing augmentation, where human ingenuity and robotic precision amplify each other. Create something better together.
Like that quote from Burkhard Buckham at Hexagon.
Oh yeah, that's a good one. The real magic lies not in machines replacing us, but in how quickly they're learning to work with us. That sums it up perfectly.
And that other quote from Lucas Siegler, the robotics evangelist, AI needs a body and robotics needs AI. That really hits home on this convergence, doesn't it? It feels like it changes how we even think about intelligence.
It absolutely does. It's about intelligence having a physical presence and interaction.
Okay, so beyond the cool tech, what's really driving this accelerated adoption? Is it just about making things more efficient, or are there deeper things at play here, economically or socially?
Well, efficiency is part of it, sure. But the economic case is getting much stronger, especially where labor is scarcest.
Scarcest how?
Demographics, mainly. Over 50 countries are actually seeing their working-age populations shrink. In the U.S. alone, they're projecting a 1.9 million person skills gap in manufacturing by 2033.
Wow, 1.9 million. So this isn't just about, cutting costs.
No, it's becoming about sustaining entire economies. Mario Maurer from Maxon Group put it very bluntly, automation isn't optional, it's the only way forward.
So it's moving from a nice-to-have for efficiency to almost an existential necessity, not just automation, but resilience. Is that fair?
That's a great way to put it. Resilience is key. And Lucas Siegler adds another layer. He points out that, Gen Z isn't exactly lining up for jobs in warehouses or chemical plants.
Right, but they still expect the results.
Exactly. They expect fast fashion, one-day shipping. So there's this gap between workforce availability and consumer demand that needs filling.
And companies are seeing actual results from using robots to fill that gap.
Oh, yeah. E-commerce leaders, for example, have already deployed over 750,000 robots, and they're seeing double-digit productivity gains in their logistics operations.
It's interesting how Spencer Huang from NVIDIA framed it. Robots don't serve countries or companies. They serve people.
That's a powerful perspective.
And Anthony Hartke from Turner Construction echoed that, saying robotics is about freeing up people to do the soft, squishy brain stuff where our people shine. So it's about elevating human work.
That seems to be the goal, yes. Elevating, not just replacing. And the stakes here are really high. Look at Asia Pacific. They account for 70% of new industrial robot installations.
70%.
Yeah, that region is actively reshaping global competitiveness. And worldwide robotics revenue, projected to hit over $50 billion this year. It's serious business.
Okay, so that vision of robots amplifying what humans do,
Yeah.
it makes you wonder, what are they actually doing right now on the ground? How are they starting to work with us in real terms?
Well, the factory floor is widely seen as the perfect playground for robotics to scale first. That's according to Burkhard Bookhem.
Makes sense. Controlled environment.
Right. So over the next 5 years, we're likely to see major growth in cobot deployment.
Cobots.
Yeah.
Collaborative robots. Working alongside people.
Exactly. Designed to work safely side by side with humans. And alongside that, AI-powered autonomy will let robots work in much more dynamic, less predictable environments.
So less structured spaces.
Yes. Amit Goel explains that robots aren't just static machines anymore. These foundation models, they give robots a semantic understanding of the world. It fundamentally changes how they operate.
Semantic understanding.
Yeah.
So they're starting to grasp the meaning of things around them, not just coordinates.
Pretty much. They understand context better.
Yeah.
Spencer Huang points out that robots are proving really valuable just by automating those repetitive, often injury-prone tasks,
Freeing people up.
freeing up human talent for higher value, more complex roles. And Dr. Juliet Aiken encourages us to think about robots more like teammates instead of tools.
Teammates.
Mm-hmm.
That's a different mindset.
It really is. It opens up possibilities for healthier, maybe more flexible work relationships.
So the immediate game plan isn't this, like, grand vision of robots doing everything perfectly everywhere. It's more targeted, focusing on the dirty, dull, and dangerous first.
That seems to be the pragmatic path forward, yes. Burkhard Bookham's very clear. We're not there, and that's okay.
Right. Manage expectations.
Exactly. The near-term focus is on those dangerous, repetitive, or tedious tasks where robots can deliver real, tangible value right now. Arnon Robert emphasizes that spatial intelligence understanding space and better sensor fusion are absolutely key for humanoids, especially to perceive and adapt reliably.
Okay, this all sounds incredibly promising, lots of potential benefits, but what's holding things back? What are the big hurdles stopping these robots from being everywhere already?
Yeah, the report really dives into this. It identifies what it calls a negative feedback loop. It's this cycle creating challenges across technical, commercial, psychological, and ethical areas.
A negative feedback loop.
Yeah.
How does that work?
It's sort of a cascade. Engineering limits drive up costs. Higher costs lead to more scrutiny. More scrutiny fuels public anxiety. Public anxiety leads to tighter governance. And tighter governance raises the technical bar even higher, bringing you back to the engineering limits.
Wow, okay. That's tricky. Let's break that down. The technical barriers first. What specifically is stopping the machines themselves?
Okay, technically, power is a big one. Actuators are power hungry, limiting battery life for mobile robots. Perception is still patchy in unstructured, messy human spaces.
They struggle with unpredictable environments.
They do, and there's a big lack of large-scale, real-world training data, especially for manipulation. Spencer Huang highlights this: robots need to understand how things behave when you touch or move them, not just what they look like.
Like the physics of interaction.
Exactly. He says we need a baseline corpus of manipulation data, kind of like how books and blogs fueled LLMs.
Interesting analogy.
And Mario Maurer argues, maybe controversially, that robots don't always need human-like hands. Often, smart, modular end effectors designed specifically for the job are more practical.
So specialized tools instead of general-purpose hands.
Sometimes, yes. And Lucas Siegler adds another point. Getting from 0 to, say, 80% functionality can be remarkably quick now. But that final 10–20%, getting from good to really reliable and exceptional, that's where progress slows dramatically. Physics and complexity kick in.
Okay, so technical hurdles are significant. What about commercially? High costs are obvious, but what else stops businesses, especially smaller ones, from diving in?
Right. Beyond the tech, high capital expenditure, that upfront capex is huge.
Hmm.
Then there's the difficulty of integrating with existing, often old legacy systems.
Ripping everything out isn't an option.
Not usually, plus you've got significant cybersecurity overheads, and often a pretty unclear return on investment, or ROI. It's hard to calculate, especially for SMEs.
And hitting costs, too.
Definitely. Chase Williams points out that installation, training, ongoing maintenance, these costs are often seriously underestimated. And the lack of universal safety standards makes liability a big worry. Who's responsible if something goes wrong?
That's a major question.
Mario Maurer adds that companies tend to fixate on the shiny robot itself. But the real complexity is often everything around it: operations. Who owns the data? Maintenance schedule.
The whole ecosystem.
Precisely.
Right.
Anthony Hartke stresses how important it is to collaborate with vendors early on to make sure the tool actually fits the real workflow. And Burkhard Bochum advises focusing on simpler, targeted applications first. Solve specific problems reliably. Don't chase full autonomy if you don't need it.
Just because you can doesn't mean you should.
Right. And Lucas Siegler notes that industrial settings demand near perfection, like 99.999999% accuracy. That's an enormous hurdle for new tech trying to integrate into facilities that already have high KPIs for reliability.
Okay, tech and commerce are tough. But then there's the human element, the psychological barriers. How do people really react to robot colleagues? Are there unexpected impacts?
This is fascinating. While we tend to celebrate getting rid of boring, repetitive tasks, Dr. Juliet Aiken warns we forget something important.
What's that?
Those repetitive tasks sometimes give our brains room to breathe, a sort of natural rhythm. If you strip jobs down only to the complex parts, you risk relentless cognitive strain. Or, the opposite, dull machine babysitting. Neither is good for mental health.
That's a really counterintuitive point.
It is, but on the other hand, Anthony Hartke from Turner Construction, he shares really positive staff reactions, employees actually showing off the robots they work with.
Oh, interesting. Pride, almost.
Yeah, and an expert from a major German manufacturer mentioned genuine curiosity and openness among their employees too, so it's not all negative.
But expectations matter.
Hugely. Lucas Siegler cautions against overhyping what robots can do right now. If you set expectations too high and the tech doesn't deliver, you risk public disillusionment. People might feel the whole robot revolution fizzled out.
Right. Under-promise and over-deliver might be better.
Potentially.
Okay, and the final piece of that negative loop. Governance. Ethics. Regulations.
Yeah.
How do we navigate that minefield, making sure this powerful tech aligns with human values?
This immediately brings up values, as you say. Dr. Julia Aiken points out that automation naturally tends to reflect the values embedded in it, often efficiency, standardization.
Which aren't necessarily human values.
Exactly. They're not inherently human values like empathy or creativity. So we risk building systems that are profitable, but as she puts it, soulless, if we only design for output.
That's a sobering thought.
And safety is paramount. Mario Maurer acknowledges that accidents will happen with complex systems. What matters is how quickly and transparently we learn from them, turning safety into a kind of social contract.
Learning and adapting.
Yes. Chase Williams notes that poorly designed automation can also lead to user confusion or over-reliance, which creates new risks. And Anthony Hartke is very clear. There's no tolerance for risk when it comes to data or connectivity, especially when dealing with government-level security.
Makes sense. And standards are still lagging.
Particularly for newer forms like humanoids. That expert from the German manufacturer stressed the lack of agreed-upon ISO safety standards for humanoids is a major barrier to scaling them up in the real world. You need those standards for widespread trust and adoption.
Okay, so despite all those challenges, technical, commercial, psychological, governance, the report still looks ahead quite boldly to 2035. It reminds us of Amara's law.
Right, we tend to overestimate the effect of a technology in the short run and underestimate it in the long run.
So keeping that in mind, what could that future actually look like in, say, 10 years?
The report lays out 3 possible scenarios, 3 potential worlds. First, a robot revolution.
The full-on transformation.
Pretty much. Robots handle most repetitive physical work, manufacturing, logistics, frontline services. Human labor pivots hard towards design, oversight, high empathy roles. Sovereign wealth funds are competing for robot dividends, and the cost of owning a humanoid drops below emerging market wages.
Okay, that's one extreme. What's the other?
The cautionary tale. This is where things go wrong. Edge AI stalls. Public trust collapses as workers get displaced without alternatives. Cyber sabotage triggers prohibitions. Governments impose strict robot licensing, capping how many can be deployed. A big factory accident or maybe a surveillance scandal ignites a kind of neo-Luddite movement pushing back against the tech.
Not a great outcome.
Definitely not.
So the third scenario is presented as the most likely, a managed mesh.
Managed mesh. What does that entail?
It's more of a blended reality. Maybe around half of industrial and service tasks are robotized. Big companies, Fortune 500s, have robotics as a standard line item in their operational budgets, not just capital ones.
So more integrated into regular operations. Yes. Robots fill predictable roles in semi-structured places, e-commerce fulfillment, urban maintenance, maybe healthcare assistance. But the scenario also includes things like mandatory annual cyber-physical stress tests, probably after some high-profile supply chain hack forces the issue.
Given all the challenges we just talked through, it's really striking that the experts seem to lean towards this managed mesh. Not just robots win or robots fail, but something more integrated, more human-centric.
Exactly. Within that managed mesh idea, their individual visions become really compelling. They paint a picture of how that collaboration could actually work.
Like what? What are some of those specific visions?
Well, Chase Williams imagines these round-the-clock warehouses, swarms of robot couriers using predictive control, making online shopping cheaper, faster, maybe even lower emission. And he sees falling hardware costs spreading those benefits to factories and farms, too.
Okay, logistics and beyond.
Spencer Huang envisions a future where you can basically buy a robot that fits your specific environment and then just tell it what to do, using natural language or just showing it.
Wow, like training a pet.
Kinda. Enabled by a more open-source robotics ecosystem where developers share knowledge. Dr. Juliet Aiken sees automation potentially helping rebuild the middle class.
How so?
By replacing the need for expensive degrees with more accessible technician pathways and apprenticeships focused on operating and maintaining these systems.
Interesting. Shifting the skills needed.
Anthony Hartke, the construction guy, imagines every crew having a logistics robot. Basically a pack mule moving materials and tools around the job site efficiently.
Practical.
Christopher Wall foresees task-unified machines. Robots that can do multiple things at once on a construction site, scan the floor flatness, check worker safety protocols, maybe even help finish a floor, all in one trip.
Increasing efficiency dramatically.
Amit Goel predicts robots arriving with built-in intelligence, usable almost straight out of the box in factories or warehouses, just needing simple demonstrations to get started.
Lowering the barrier to entry.
Burkhard Bacom sees humanoids becoming just a natural part of the industrial landscape, learning by imitating humans and adapting to new tasks over time.
Blending in.
And Lucas Siegler really emphasizes robots solving real problems. Mobile manipulation becoming standard, but only where it delivers genuine business value, not just because it's hyped up.
Value over novelty. Okay, so if that managed mesh is the most likely and hopefully best future, how do we actually steer towards it? What's the practical roadmap to get there and avoid that cautionary tale?
This is where the report gets really prescriptive. It argues strongly that we must see autonomy not as a substitute for people, but as a scaffold. Something that amplifies human capability and actually widens opportunity.
Scaffold. I like that.
It means investing in skills first, designing systems for transparency and dignity right from the start, and, critically, measuring success not just by throughput or efficiency, but by shared prosperity. Does it benefit everyone?
Shared prosperity. That's a high bar. The report mentions 3 key design principles for this roadmap. Design for dignity, deploy with empathy, evolve with trust. Can you break those down? What do they mean in practice?
Sure. Design for dignity means embedding inclusive, accessible user experience from day one. It means building the requirements, the interfaces, even the safety cases with the frontline users, not just for them.
Getting them involved early.
Exactly. Deploy with empathy is about piloting in real workplaces, using phased rollouts. You need those live feedback loops to find the friction points, the trust gaps. Mario Maurer stresses this. Scaling robotics is an enterprise transformation project, not just buying some hardware.
It's a bigger change management process.
Absolutely. And finally, evolve with trust. This means continuously refining the systems using transparent metrics, treating adoption not as a one-off event, but as a living relationship that requires ongoing updates, reskilling for the people involved, and iterating on the governance.
It's striking how many of these experts keep coming back to collaboration, that human-first approach. It feels like a deliberate counter-narrative to the initial unease we talked about.
It really does. Lucas Siegler urges a shift in how we talk about it, focus on how robots are helping businesses stay afloat, creating stability, maybe even saving jobs in some contexts, not just displacing people.
Changing the story.
Burkhard Bochum stresses the practical side. When people work physically close to machines, they need to feel safe, comfortable, in control. That influences everything from the materials used in the robot to how it moves.
The whole user experience.
Chase Williams suggests things like robotics as a service, RAS, to make it more accessible, turning that big upfront capex into a predictable operating expense like a subscription fee. He also highlights the need for interoperability systems working together and much better training.
So the message seems to be, the future isn't about one giant company or one magic technology solving everything.
Absolutely not. It's much broader, more interconnected. Spencer Huang strongly advocates for democratization, making it easier for anyone to train and retask robots, maybe using natural language. He sees robotics as a global open-source mission.
Sharing the knowledge.
Amit Goel calls robotics a massive systems problem. He figures it requires the convergence of at least 50 different technologies. His conclusion: no way any one company can solve all of it alone. Building an ecosystem is absolutely essential.
The ecosystem approach.
And Dr. Juliet Aiken brings it back to the human experience. The brain needs variety to thrive. We need to ask, what kind of work feels meaningful, not just productive? How can automation support that?
A fundamental question.
Ultimately, as Arnaud Robert points out, the bottom line is ensuring all these amazing advances actually translate into real business value. It has to work economically, too.
It sounds like change management, that whole process of adapting, really becomes the hidden architecture of robotic success.
That's a great way to put it. Hexagon's vision seems to exemplify this consciously engineering empathy into autonomy, ensuring robots operate in harmony with people, truly augmenting human capabilities, not just replacing them. They started, apparently, by putting intelligence into machines simply to make life easier for people. That principle seems to be carrying through.
You know, this whole journey from the earliest automation to today's robot renaissance, it really feels like at its heart a story about humanity's constant desire for progress and how we design the tools that shape our world.
That's a nice way to frame it.
This deep dive, I think, really shows us that the future of robotics isn't just about what machines can do. It's fundamentally about how we choose to design them to work with us, to amplify our capabilities, and ultimately to solve our most pressing industrial and societal challenges.
Which inevitably raises an important question for you listening right now. Given all these insights, the tech, the business case, the human factors, the governance, how might you start to evaluate the role of automation in your own life or work?
Right. What steps could you take in your context to ensure that as this technology advances, the focus stays firmly on human flourishing and purpose, and not solely on, say, efficiency?
Something to think about.